Once again, matriculants, um, geography teachers, and people who are curious in learning more about geography. And today, we are going to be looking at discharge of a river. Okay? Yes. I'm just going to explain and give you definition and tell you the factors that are affecting a discharge of a river. Right? Yes. Okay. A discharge of a river. Okay, let's just give a definition. I can say discharge of a river is the discharge is the volume of water which flows through it in a given time. And this water is usually measured in cubic meters per second. It is usually measured in cubic meters. Cubic meters per second. Okay, and then the volume of the discharge will be determined by factors such as climate, vegetation, soil type, drainage basin relief, which we can also say it's a slope, and the activities of men. Okay, so let's first talk about the definition so that you can understand, so I can create a deeper understanding for you guys. It is okay. Discharge of a river is the volume of water which flows through it in a given time, right? So a discharge of a river, this means it's a water inside a river valley, right? It's water inside a river valley. The amount of water inside a river valley. That's a discharge of a river in a given time. And then this volume of water, it usually measured in cubic meters per second, right? Yes, so the amount of water passing through an area can be measured, right? Okay, and then in terms of the factors that are affecting this discharge of a river, the first one I can say it's a gradient, which is I can also say it's a relief. Number two, vegetation, the soil type, and activities of men, right? Yes, so we can say here the volume of the discharge will be determined by factors such as climate, vegetation, soil type, drainage basin relief, and the activities of man. Yes. So the volume of the discharge will be determined by factors such as climate. How? Of a climate. Okay, let me explain of a climate. If an area it's an arid area, that means it receives little or no rainfall at all. It is going to affect its river. So the discharge of a river will be very low because there is no rainfall occurring in the area. The area is very dry. But if the area is receiving more precipitation all around the air, meaning that the discharge of a river will be full at all times. Right? The discharge of a river will be high. Right? Or more discharge. The vegetation is a factor of a discharge of a river. I can say if there is more vegetation on the land around the river or on the drainage basin around, more water will be absorbed by the vegetation. That means there will be infiltration occurring, right? Then water will not succeed its runoff to the river, and therefore there will be low discharge of a river, right? Yes. So if there is less vegetation or no vegetation at all around, there will be high surface runoff, right? Yes. And therefore meaning that the volume of the discharge will be higher because there's more runoff potential to the river, causing the river to be full, right? Yes. So the soil type a soil such as let's say a sandy soil, you can see it has particles and so on. So it's kind of a particles, and therefore it absorbed water easily. The sandy soil, like a soil that is like a sandy and so on, and therefore there will be a rare runoff of water, so there will be less surface runoff. Then if there is maybe a clay soil type, you can see they are closely packed. It's something that is solid, so there will be high runoff potential, right? Yes. So there will be high runoff potential, meaning that the water will cause the high discharge of a river, right? Yes. Yes, that's how it goes. Guys. And now let's look at the river flow. We have two types of river flows: the laminar flow and turbulent flow, right? Okay. Looking at the river. looking at river flow, right? Yes. Okay, let's look at river flow. We have a laminar flow and turbulent flow. A laminar flow, this is a flow whereby the water inside the river is flowing fluently, right? Yes. But a turbulent flow, this is whereby the water is flowing irregular. There are fluctuations and so on. So it's irregular, a turbulent flow. Then a laminar flow, it's smooth. It's a smooth flow. Yes, I can say. So we have a laminar flow. We have two types of flows. One, let me say one. Let's talk about laminar flow. Laminar flow. Laminar flow. Okay. So a laminar flow, it flows parallel with no disruption between the layers. So it flows parallel with no disruptions. Between that is a laminar flow. So a laminar flow, it flows parallel with no disruption between the layers. Okay, and so let's see a laminar flow. I think you can see a laminar flow there at A, then turbulence flow, it's a D, whereby there is a lot of friction causing water to flow in a turbulent way. Yes. So a laminar flow, meaning that the river bed is so smooth, so it's going to flow in a laminar way. And then a turbulent flow, this is by a river bed and the sides are full of rocks and so on, causing friction to the flow of water and ending up to be causing a turbulence flow. Okay, yes. So that's a laminar flow there at A. Then at D, letter D, it's a turbulent flow. Yes. Yes, so let's draw this laminar flow. How it's going to fall. Let's say these are the edges of a river. This is our river. This is the river. The sides of the river. This is the flow of water. It's flowing with no friction. Flowing smooth. You can see it's flowing smooth. A laminar flow. This is a laminar flow. Flowing smooth, the water inside the river flowing smooth. Yes, that's how it goes. Yes, it's easy, guys. A laminar flow, it flows smooth or smoothly. Yes, and then let's go to a turbulent flow. Okay, let's see number two. This is the two. Number two. Let's talk about turbulent flow. Turbulent flow. Okay. So you can say turbulent flow. The water inside the river undergoes irregular fluctuations or like some kind of mixing and so on. Yes. Water inside a river. Water flow inside a river undergoes irregular fluctuations. Or we can say mixing. Yes, mixing. Yes, and then the speed of the water inside the river at a point is continuously undergoing changes in magnitude and direction, which results in swelling and like cycling in a cyclic way. And water will move in a cyclic way, because of that friction, as the bulk of the water inside the river moves in a specific direction, right? Yes. So you can say the speed of the fluid. Oh yes, you can say the fluid is water, guys. The fluid at a point. The point is continuously undergoing changes in both magnitude and direction. That's it. That's a turbulent flow. Yes, can also be caused by winds and so on, but mostly caused by sediments in the riverbed, rock layers, and so on, causing water to move in a turbulent way. Yes. So, by looking at our image, you can see that a D, it's a turbulence. Yes, it's turbulence. Therefore, it's a turbulent flow. Yes, so that's how it goes. Yes. So let's draw our water will end up moving in a turbulent flow within a river. This is our river. This is our river. It's our water. See? Move like this. Water move like this in an irregular way, while the laminar flow moves in a regular way, in a smooth way. You see this one? Move in an irregular way, causing water inside. You see? Yes, this is a turbulent flow, which is it's not in a uniform way. It's not smooth. It's harsh way. Okay. Yes. Thank you so much, guys. Don't forget to subscribe, like, and comment. Yes. um See you in the next lesson. Thank you so much.